Force diagrams. A force diagram is a diagram showing all the forces acting on an object. Each force is shown as an arrow pointing in the direction in which the force acts. So let's suppose we've got a plane here and an object on that plane. One force that acts on this object is its weight, and of course that acts vertically downwards. It doesn't fall through the plane because of a reaction force, which we'll call N here, which acts between the plane and the object, and in most instances would counteract the weight. Suppose we have a force P in this direction. That might be produced by us pulling the object in this direction, and that might be opposed by a frictional force, for example. If the forces are balanced, in other words, N is equal to W, F is equal to P, then the object is said to be in equilibrium, so the forces completely balance out. An object in equilibrium will either remain at rest or continue to move with a constant velocity. The forces, however, may not be in equilibrium. So let's consider this object just here. Let's suppose we've got a 20 Newton force acting this way, 20 newtons that way, 30 newtons this way, and 20 newtons this way. It should be clear that these vertical forces balance, but the horizontal forces don't. We've got 10 newtons more acting in this direction. The resultant force is therefore 10 newtons to the right. Acceleration in these diagrams is often represented with a double-headed arrow. This object will accelerate in this direction because of the resultant force being in this direction. Using F equals ma, we have 10, which is the resultant force, is equal to the mass times the acceleration, and therefore the acceleration here would be 5 meters per second squared to the right.